Hey guys, I wanted to go through doing nitrogen balance problems when you have somebody that has open wounds. As you have open wounds, you've got a lot of drainage coming out of that, and in that drainage inevitably is going to be a significant amount of protein, and thereby, or therefore, nitrogen will be coming out and being lost as well. So I wanted to do an example that you might see as you're in a hospital looking at somebody that's had some sort of trauma. So if you remember, a nitrogen balance is basically like every other balance equation, nitrogen in minus nitrogen out. For the nitrogen in, basically we just need to look at the protein that's coming in through whatever route. If they're taking protein in PO, if it's coming in through tube feeding, or if it's coming in through TPN. We need to account for all the protein that's going in. And we'll convert that protein into nitrogen. Basically, 16% of a molecule of protein is nitrogen. So if we basically take the protein intake times 16%, we will get the nitrogen intake. For nitrogen out, you basically have three routes of loss. You have urinary loss, which is the majority of where nitrogen is lost. You also have losses, as we spoke about, from those open wounds. And then you have some loss as you shed enterocytes in your feces, and then coming out also through skin and fingernails, hair, that type of stuff. So three routes basically: urinary loss, open wound losses, and fecal skin, etc. So for nitrogen out, as we're looking at the urinary excretion side, there's actually two different compartments for urinary nitrogen. First of all, and the majority of it is all in the form of urea. You know that urea is the excretory form of nitrogen in the body, and you're basically making urea in your liver so that your body doesn't build up with large amounts of ammonia. So urinary urea nitrogen makes up about 80 to 90% of the nitrogen that you'll excrete through your urine. However, there are other forms of nitrogen that are non-urea nitrogen that you will also excrete through your urine. And those other forms make up about 10 to 20% of your total urinary urea nitrogen. So total urinary nitrogen is basically, if you take your urinary urea nitrogen and multiply that by 1.2, that will make up for the other 10 to 20% that's non-urea, and that will give you your total urinary nitrogen losses. As far as wounds go, depending on the amount of body surface area that has an open wound, you have varying amounts of nitrogen being lost depending on body size. So if less than 10% of the body has open wounds on it, then you're going to use a factor of 0.02 grams of nitrogen per kilogram per day. If the open areas make up 11 to 30% of total body surface area, then you're going to be losing 0.05 grams nitrogen per kilogram per day. And if you have open areas larger than 31%, if you get much higher than 31%, you're going to die. But if you're over 31%, you're going to be losing about 0.12 grams of nitrogen per kilogram per day. So that takes care of the urine losses and the wound losses, and the other losses are basically just an estimation. Fecal, skin, etc. For most cases, you're just going to use a standard factor of 2 for that. However, if you have somebody that has significant diarrhea, or if they've got an ostomy and are having a lot of output through that ostomy, they might be losing up to 4 grams. So if they have a lot of diarrhea, ostomy losses, again, you're going to use a factor of 4 there as opposed to 2. But generally use a factor of 2 to account for the nitrogen loss from skin and feces and other sources. So I want to do an example now of somebody that had some significant trauma. Let's say they had a burn, and they're in an ICU and they're getting TPN And the amount of protein in the TPN, they're actually, the TPN prescription for protein is 1,500 mils of 7.5% amino acid solution. For the tube feeding, they're also getting a tube feeding, and again, you can see that this rate, impact, which is 56 grams of protein per liter, is only running at 25 cc's per hour. So this rate is basically just a little more than a trickle rate, just to keep the gut active and to prevent bacterial translocation. So we've got two different sources of nitrogen coming in, again, TPN and tube feeding. We have urinary nitrogen that was measured in a lab. We did a 24-hour urine collection, and they came back with a urinary nitrogen of 901 milligrams per deciliter. Again, remember, this is a concentration. 901 milligrams of nitrogen are being excreted per deciliter of urine. And we did a 24-hour output, and the output of urine that this resident has is 2,180 mils total output. And again, assume this person had a burn and they've got 20% open wounds. One other thing I didn't have on here that I do need to add, let's assume that this patient weighs 68 kilograms. Okay? All right, so let's take a look at how we're going to calculate nitrogen balance for this patient. First step is to determine nitrogen in. So again, we've got two different routes of nitrogen coming in. We've got our TPN, and that TPN, the order was 1,500 mils, 1,500 mils, and it was 7.5% amino acid. So I'm just going to go and put that in decimal form, 0.075. And we end up, if you do this math, 112.5 grams of protein coming in from the TPN. We also have this resident on a tube feeding. And again, it's running at 25 mils an hour continuous, so 25 mils an hour times 24 hours a day is going to give us a total volume of 600 mils. Again, it's not a lot. And then the formula that they're using was impact. If you remember, I said that impact is 56 grams of protein per liter. And if we take that concentration of protein and we multiply it by the total volume that we're getting, 600 mils, which is the same as 0.6 liters, then our total protein that they're getting from the TPN, from the tube feeding, is 33.6 grams of protein. So, total nitrogen in is our 112.5 from the TPN plus 33.6 coming in from the tube feeding, which is going to give us a total in of protein, this is protein in, of 146.1 grams. Okay? Again, that's protein, that's not nitrogen. To convert it to nitrogen, we have to multiply it by 16%. So if I take 146.1 times 0.16 for my total nitrogen coming in, 2338. Okay? I'm going to go ahead and highlight that. So that's our total coming in. So now we need to figure out how much we have going out. So first we're going to look at the urinary side for urinary losses. So this is nitrogen out. Number 1, urinary. So we know from our labs that we pulled back here, where did it come from? The labs, we had our urinary urea nitrogen, 901 milligrams per deciliter. So if I take that 901 milligrams per deciliter, for working with this, again, when we do nitrogen balance, we're always talking about grams of nitrogen. So I need to convert this into grams. And as we talk about volume of urine, we generally talk in terms of liters a day. So I want to convert this 901 into grams per liter. It makes the math much easier going forward. So if I do this, that's actually 9.01 grams per liter. Okay, just simply move the decimal point over 2 places to the left to go from milligrams per deciliter to grams per liter. And then we had our output. Let me come back here. Our 24-hour urine output was 2180 mils. So if I take our total output, 2180 mils, and I'm going to convert that into liters, again to make the math easier, 2.18 liters. Okay. So now I have my concentration of urine, or of nitrogen in the urine, is 9.01 grams per liter. And I know my total volume is 2.18 liters, so if I do the math and multiply those, I'm going to get my total, or my, rather, urinary urea nitrogen. And that's going to be 9.01 grams per liter times 2.18 liters, which is going to give me 19.64 grams. Now remember, that's urinary urea nitrogen, which makes up 80 to 90% of total urinary losses. You do have a little bit of ammonia that you will be excreting, and a couple of other non-urea nitrogen products. So we're going to take our urinary urea nitrogen and multiply that by 1.2 to get our total urinary nitrogen. So if I take 19.64 times 1.2, I'm sorry, that's in grams, times 1.2, I'm going to end up with 23.57 grams total urea nitrogen. So that's how much we're losing through our urine. So the second thing we want to look at is the amount that we lose through wounds. And I told you it was a 20% open wound, and if you go back and take a look, for 20% open wounds, we're going to end up using this range right here, which is 0.05 grams of nitrogen per kilograms per day. So let's come back to where we were. So if I take the right pen up, 0.05 grams per kilogram, and I multiply that by, I told you this person weighed 68 kilograms, that's going to give me 3.4 grams of nitrogen coming out. And then the third place that we look is, again, skin, feces, etc. And I told you, unless they have an ostomy, or if they're having lots of loss through diarrhea, if they have those cases, you use 4 grams as a rule. However, this person doesn't have that going on, so we're only going to use 2 grams for our other losses. So now I'm going to have to add my 2357 from urine, my 3.4 grams from the open wounds, and then my 2 grams that's coming from skin. And when I do that, 23.57 plus 3.4 plus 2, and these are all grams of nitrogen. That gives me 28.97 grams of nitrogen. Okay, so now to do our balance, we're going to take our nitrogen in minus our nitrogen out, and if we come back here, our nitrogen in was 23.38. And we subtract from that our nitrogen out, which is right here, 28.97. Again, these units are all grams of nitrogen. Then my nitrogen balance is going to be at minus 5.59 grams per 24 hours. Okay? And again, that's about what you'd expect for somebody that's gone through significant trauma like a burn, where they've got large, massive open areas where they're losing, again, serous protein from. So anyway, that's how you do these nitrogen balance problems when you have open wounds. So this is here for you guys to review whenever you want to. Hope you all have a great day. Bye.